All right, welcome back, and here we are again. My name is Corey, and this is the series where we are building a programming language from scratch using C++ and, uh, yeah, those basic tools, Bison, Flex, and our text editor, Vim. Doing everything in the console, everything in the terminal window. And our last episode was where we did some restructuring. There wasn't a lot of advancement, rather, it was a simplification of our code base. And using being thankful for our unit tests because they assured us that everything was still working as it should. There's one or two other things I know we need to do, but I want to add something that we've been missing, and that is we've got our booleans, true and false. What we don't have is a logical not. And we have a negative, right, for numbers, right, a negative number, and it is a unary expression, right? That is, it takes one operand, excuse me, takes one operand and an expression of some sort, and we want to kind of reuse that same structure, so we're going to rename the negative AST node as unary, just like we have binary now for all of our addition, subtraction, multiplication, division, and modulo. And we will continue to use it when we do start doing comparisons: less than equal to, greater than equal to, the double equal, and not equal. And yeah, so sorry, my brain just stopped working. It is kicked back into gear. We're good to go. All right, so we're just going to jump in, and we are at the place that we were last time. That is episode 19 was the last one. This is episode 20. And so we will, whoops, clear. We'll go from there. And we're going to start off by moving. So git mv, git move, and we're going to move the source AST node negative, and we're going to move that to source AST node unary.cpp. All right, we're going to do the same thing, git move for the include AST node negative, and we're going to call that now include AST node unary.hpp. And at this time, we now need to, let's go ahead and change our make file. So our make file, and now node binary. Now we've got the boolean, cast boolean. We're going to do the same thing with cast pretty soon. Float integer. There it is, negative. Instead of negative, we want unary or unary, whichever one. And if I just negative, there we go. And I should be able to for 71 and 72 substitute negative for unary. There we go. And now we need to start making our change. So let's go ahead and open our include AST node unary and our source AST node unary. A couple things we're going to do. First, we need to, for everything, we're going to substitute negative with unary. We did that. And we're going to do another substitution of negative unary, different capitalization. That's fine. And there may be a faster way of doing that. I just don't know what it is. And I'm going to go ahead and write that and go to buffer 2. That way I can do the exact same thing. I don't think I've got, well, I don't think I wanted to do that one yet, but I'll do the other one. All right. right, and go back to buffer 1. Now let's see, what changes do we need? First of all, so we need a struct, not a struct, an enum. And oh, I didn't write documentation for the enum from the episode from yesterday. I'll have to do that. And this will be the type of operation. And let's just say this is enum operator. And it's going to be, well, right now, negative. And we also know that not is what is coming up soon. Okay, so now we need to pass in operator op, and we need to store the operation, which will be applied to the operand. Sure. Operator op. All right. So far, we're looking pretty good. So we have added an enumeration class that we're going to pass to the constructor, and now we're about to go into the CPP file to tell it how to store it and what to do with the compile. But so far, so good. So let's go to buffer 2, and now we need to tell it, first of all, in the constructor, it should be that there is an operator op coming across, and after AST node location, now we need to say op. There we go. Passing it through. And now we need to do the same thing that we did before, and that is we need a pound include string, and oh, we're already returning a string, so oh well, doesn't matter. So it's going to be a string. What did I call this in the other one? Simple enough. Let's just less the source for AST node binary and there, description. Yeah. Description equals, and now we'll do what's the first one? Negative, because they need to be in the same order, right? And then not. All right, and now we will say Unary plus description of this op plus that. Now I think we're going to do that. Okay. For the compile, we need to do what we did earlier, or on the other one as well. TCA switch this op and case negative. Like, why is it not matching up? And this is going to be not, and opcode. Oh, we need to make this opcode. not. Okay, opcode not. There we go. And to make a copy, we call make copy, which, oh, we also need to pass in this op. There we go. Now, as of this moment, well, except for the opcode not existing, so we can actually add that. I was going to say it should compile, and all the tests should run just fine, except we're referencing an opcode not that doesn't exist yet. So let's do that. Let's edit the source, not source, include. I always get those backwards, and I don't know why. Opcode. And where do we want to put this? Modulo negative. I think I want to put it after the negative. And we're just going to say not. And pop val push logical not of val. Okay. At this point, like I said, this should work. So let's just do make test watch. Oh wait, what did we get? Undefined reference to node negative, shared pointer location. Where is that? That's the constructor. So which one did I mess up in? The constructor has the oh, yeah, it's calling AST node negative. What is AST node negative? Or where is that? That will be in the why did it get this far is the question mark. I think it's because, whoops. I think it's because I didn't do a make clean, make test watch. And now I think it's going to be in the bison stuff that it should be giving us a problem. Yep, there we go, bison. Nope, didn't mean to do that. Edit bison, and so let's go down to where the includes are. Not that one, this one down here. We no longer need negative, we need Unary. And I'm going to put that up here because I want to. And then down here we make a shared, not negative, but Unary. And this is going to be Unary And this is the negative. There we go. Everything passes. That's a good thing. Now we can do our not. And it's the previous times when we've added something new, we've had to, add something to our makefile, add something to, or we've added new files. Of course, change flex and bison, all that stuff. This is going to be simpler, and you're going to see why it's so good. And so we'll still have to add the program, dump, and execute stuff. But again, this will go so much faster. Excuse me. So let's open the. Let's do flex. Well, no, wait. We're in bison right now. Let's do bison first, and let's move down some. And we want to have a not. Let's put it right there. Percent token. And I'm not going to call it not. I'm going to call it exclamation point. Why not? Again, the user will never see this. They will see the user-friendly name. But that's fine. Exclamation point. And now we need to know the precision of it. Do I still have my... It's with the Unary. You know what? It's with the Unary. I already know that. The Unary minus and as. So let's just add the exclamation point there. And it's gonna, whatever. Down at the bottom, now we're going to say, there's the casting, there's the addition, subtraction, there's the minus. I think I want to put it before the minus. There's no reason why other than it's a Unary and the other is a Unary. So it's going to be an exclamation point. Now I am purposefully choosing the exclamation point. Again, if you're writing this, you could choose the words NOT like Python does, for example. Or you could make up your own symbol. I'm just using this expression. Now, I don't have to put up above, I had to put precision U minus. And why did I have to do that? Because the minus sign is used for two different tokens. It has been used for the negative, for minus, as in some expression minus another expression, and it's being used for the Unary minus. And by default, Bison doesn't know which one that's referring to, let me back up. Bison doesn't care. The problem is that they have different precedences. So in this line 204, I'm telling it when you see the minus in this location, use it or interpret it with the precedence of the U minus token that I declared above. And it's right associative, and it has the same precedence as and now the exclamation point. But since I'm not using the exclamation point anywhere else, I only have to give it the one time. So what is this? Standard, you know what? There. Unary, and now not. There. Now I have to tell Flex what to look for. Okay, so let's edit Flex. And for this, we just go down, and we've got all of our symbols here. We've got our true, false. I'm probably going to put it down around the actual symbols. And there we go. And we'll do an exclamation point. And we will say make, whoops, exclamation, nope, all one word, Corey, exclamation point. The question is it going to redo everything now? It should. Okay, now I could write the code, but because, well, let's do it. Let's write our test code. There we go. And this will be not. Not true should be false. And not false should be true. Now, we're not going to get that. It's going to give us an error saying, hey, I don't know what this opcode is. Yep, error, unrecognized opcode. Why? Because we haven't told the program what to do when compiling it. But let's do that now. So we're going to edit our source program. Let's do the dump first. Why not? Where do we put that opcode? We put it right after negative. Okay. So negative, there we are. And this is now going to be not there we go. Simple enough. And now we need to do the same thing with the source program execute after negative. So after negative, there we go, y7. And this is going to be not there needs to be one thing on the stack. There needs to be, yep, pop back, that means remove it. And now we're going to do the not. And now we don't know how to. We haven't written this. An operand is a garbage collected value. So we've got to write that next. And yep, garbage says don't know what to do with that for garbage collected. So let's edit first of all the include for garbage collected, and just look for the operator stuff. That's the move assignment. That's here we go. We're going to be writing these for each of the comparison operators, so we can't get by that. But oh well. Perform a negation. This is going to be perform a logical not on the garbage collected value. Delete that extra space because it's bothering me. Operator not. Okay, now it's going to tell me it can't find it, but that's okay. I already know I'm already going there. Source garbage collected, and now looking for operator. Oh, the right here. Where's the minus there? We'll put it with that. Yeah, that's the negative one. Exclamation point, and now not. We don't have this yet, right? This arrow ref is, that's a computed expression, and we need to add the not procedure for computed expression. It's going to say, hey, this doesn't exist. There's no, computed expression doesn't know how to handle that. So let's add that. So it's our include for computed expression, and let's see, add, multiply, negative. Let's add a not there, yanking 6. The result of negating of the logical not of. Compute the logical not of this value. There we go. Not. Okay. We need to add the default. We haven't done that yet, so we will do that. Edit the source of computed expression. That's fine. And this is, I like doing it right after the negative. Not, and don't know how to get the logical not of. Get. Don't know how to. I don't know. Find, calculate, compute. The logical not. Okay, now we have a thing. All of our tests should run, and we'll have errors because it doesn't know how. Now we just add this to our Boolean. And so we're going to edit our include for our computed expression Boolean. And we need to do the dunder not. And now it's going to complain that it doesn't exist yet. Okay, fine. We'll do that. Source, computed expression Boolean. And not. And we're going to make a computed expression Boolean, which is just not this value. We did it right. Everything should run. I mean, all of our tests should pass. They do. Yay! Now the question is, what do we want to do about floats? And or integers. Shouldn't we be able to say not 3 and it tell us 0? Do an implicit. I think I like that idea. But it would have to be the integer or the float making that decision that it could make that computation. Okay, so how do we add that? Well, first of all, we need to edit our... Whoops. No, that is not what I meant to do. We need to... Is it buffer 1? Nope. Which buffer? Our test. Buffer 6. Let's add these. Yeah. Okay. and R3, R4, R5, and somehow... Oh, never mind. I just didn't go down far enough. R6. Okay, and what are these going to be? I think we're going to do not... three. Should be false. A not 0 should be true. How about a not 3 dot? And a not 0 dot. Okay. These will give us errors now that I've saved it because it doesn't know how to compute them. And I want to do one more. I want to... this will be 7. Whoops. R7. And then I want to make this a -3. Why? Just because. Composition. Should still be false. But, and by the way, that throws students off at first because they only think of the positive numbers. And no, negative numbers are truthy as well. You take the not of them, they'll give you false. Okay. So these are going to fail until we add this ability to our ints and floats. So in order to do that, we need to edit the include for computed expression float first. Why not? It came up first. So where's the negative? It's right there. We're going to now add the not... can't type, evidently, not. And now we need to edit the source for the computed expression float and add the... there we go. Here's our negative. We'll add our not. And this is going to be a computed expression Boolean, which is... Will it compile that? Will it complain is, I guess, is my question. And I think the quick answer is no, it doesn't. And we're down to now only 3 errors. Yeah, that's fine. Let's go back and change the our computed expression integer. And we're going to, we're down at the negative. Let's not, okay, and now we need to add that to our source. Computed expression integer. There we go. And just have to find it. I could have done the search, but oh well. Yeah, I did that right. I keep hitting the wrong keys. I'm not complaining. I'm not claiming that I know how to use this. Boolean and not this value. If we did it right, all the tests should pass. They all passed. So we have now added a not, and what do we do? You say, Corey, that's still a lot of changes. Not as many as you think. We added... Okay, let's look through it. First of all, we did add... Well, we changed the file of the Unary... of negative to Unary. Definitely, we did that. But and when we did that, we had to change our make file. That's not a normal change that we'd have to do. We added something, so it makes sense that we had to add it to Bison and Flex. Okay. This is the new stuff in Unary. Because we added a new operation, a not, we had to add it to the computed expression. and then we had to add it to the computed expressions that we wanted to act on it, right? So we might not, a string, for example, it may not make any sense to have a not value for a string. Maybe it will. We'll see. Can we convert a string into a Boolean? If it's empty, it's false. If it's not empty, it's true. Maybe. This is our language. We can make it work however we want. But if we don't need that functionality, then we don't need to add it to the language there. Wait, to the language? Then we don't need to add it to the whatever this is called. Sorry, I was reading something and just kind of forgot. We don't need to add it to the computed expression object. Garbage collected. What did we do there? Oh yeah, we had to add the not operator to it. We had to add the opcode, and these are, we've already talked about. And then we had to add the dump and the execute. Yeah, add a few tests. See if there's anything out of the ordinary. Yeah, git commit -am, and what did we do? We logical not and converted AST node negative to AST node Unary. Okay, good. And now, how are we? Oh, that was fast. We're going to do one other thing. And that is in our includes, we've got our casts. Whoops, there we go. In case you're wondering why I had to move to the outside, this is the tool I'm using. Can I pull this up? I'm using Power Toys for, it's from Microsoft. You can install it from the store. And one of the cool things it does is there is a mouse utility. Find the mouse, and you hit Control twice, and it will do this lovely little thing that I can highlight. Give myself a halo, maybe. Anyway, yeah, it does that. You hit Control and it goes away. Or if you're moving around and then you stop moving for just a second, it'll go away on its own. And yeah, it says find my mouse. But you know what? I use it in presentations all the time. The problem is, there's a lot of other stuff that exists in Power Toys. It's just, I don't know why it wasn't installed by default on Windows. It's really nice. But if my mouse is in this screen, it will not work. I can hit Control. Oh, wait, it did this time. Maybe it's if it's selected. It doesn't work, but if I move off the screen, then it will. So I could either try to fight to get it right in the middle or go to the bottom, whatever. That's the only thing. Is this captures the mouse, and if it's focused, it captures the keyboard presses, and if I hit Control twice, it does not activate. So I had to move off of it. So now that I know, I can just move off to the side and then capture it. Anyway, okay, so back to what I was going to say. We've got these three: cast Boolean, cast float, cast integer. And they also have the other stuff. What was I going to... I mean, this is in the includes directory. There's also the source files for it. And I mentioned this at the end of the last video. The reason we were able to combine the add, subtract, multiply, divide modulo is because they all shared the same type of information that they were holding. They had a left-hand side that was an expression, and they had a right-hand side that was an expression, and they all operated the exact same way. That is, they had to compile the left-hand side, then they had to compile the right-hand side, and then they could do their individual thing depending on what type it was, but everything else was the same. And that's what the node casts are. So we are going to simplify our code even more by getting rid of these 3 classes and take them down to 1. So in order to do this, now we're going to go back into our make file, and our node cast Boolean is now just going to become nodecast. Nodecast float and nodecast integer are all going away. Yes. And now we're going to look for the word cast. There we go. Nodecast Boolean is just going to become nodecast, and I need to change it here as well. Nodecast. And now we're going to get rid of these two, nodecast float and nodecast integer. So that needs to be there. And it's going to say, don't know how to make nodecast. Yeah, no, we're about to fix that. So we're going to change this. We're going to git move our include of AST node cast integer to include AST node cast .hpp. There we go. And now we're going to say git move our source of AST node cast integer to source AST node cast. All right. I was going to complain now that it doesn't know how to find some stuff, but we're about to fix that. So let's edit. Oh, you know what? I can even do this. Git rm include AST node cast float include AST node cast boolean source AST node cast float and source AST node cast boolean. So now those are gone, and now we need to edit these. So our include AST node cast and our source AST node cast. There we go. And now we're going to change. We're going to remove the capital integer. There we go. And now we're going to do the same thing for the title case. Okay, now let's read through this. Constructor. Oh, did we not add this to the documentation for the Unary minus? We might not have. I may have to go back. Param. This is going to be target type. And this is going to be the target type that the expression will be cast to. Okay, and we need to have these are the possible types that can be cast to. And an enum. What are we going to call this? Type. Sure, why not? And we will have integer, float, Boolean. All right, and we need to store that information as the target type. And we will just call that target type. All right, now we've got to anything else here? AST node cast class. A typecast. Of an expression. There, I like that better. And now, let's go here. We need to do our... No, I'm not going to do that one, but we do need to do this one. All right, so AST nodecast. Nodecast, we need a type, target type, and now we need to pass that in. Target type, cast to description. And what's the order I did? Integer, float, Boolean, let's see. Cast to target type. That should be fine. And now for the compile. Switch target type, and we're gonna say case integer, whoops, break, float, Boolean, cast float, and now cast Boolean. Am I missing anything? Have I made any stupid mistakes? Oh, the make copy. Of course. I need this target type. There we go. And There we go. And I think now that we've got to tell Bison about this, because I don't think it knows about us. Is there anything else? I mean, it's complaining about something else here as well. So let me look. Node cast. No declaration matches the node cast with target type, shared pointer to expression, and location in 7. So let's go back to... Oh, yeah, I need to add that in. This needs to be a type, target type, and oh yeah, now it just doesn't know how to make these shared pointers, so we need to edit the Bison. And there we go. So we no longer need all of these node cast types. And now there we go, node cast, and we need to say AST node cast integer. Node cast float, whoops, and node cast Boolean. That should fix everything. Hey, all of our tests passed still. That's good. That means our functionality is still there. And what have we done? We've removed 4 files, renamed 2, and made some changes. So let's see what our changes are. Obviously, makefile changes. Simplifying to just one include. Passing the right types of casts, right? These are changes to the node cast. Yep. We have these here. Do I want to add more to that? I might. Add the target task. Yes, everything. Simplify. There we go. Now, one last thing I want to double check, and that is, so I want to look at the include for the AST node cast, and for this here, we can do create a computed expression integer. cast 2. Yeah, this needs to be float, and this needs to be Boolean, and that shouldn't hurt anything. That's more just for documentation purposes. And did we do the same on our other ones? What are they? They were include AST binary. We did not. Guess what we're about to do? 3, that, and this is indicate plus. LHS plus RHS. I think I'll just leave it as that. I think that makes sense. Let's line up everything, shall we? Nope. Now the question is that enough room? Our additional operators are about to be less than, equal, greater than, equal. And so let's just see how much room that's going to take. Greater than, equal. So that's how far we're moving. Why? Because I don't want to have to change these again. This doesn't exist yet, so... Oh, and I didn't add the operator here. At param op. I don't know if that'll work. Let's try it. And then the Unary. Include AST node Unary. So no, I haven't yet. Compute the negative. There we go. And I did add the operand. No. Oh, yeah. Param op. To apply to the operand. The expression to be operate it on. I'm a doctor. I can do this. No. Let's see. The operand to which the operation will be applied. And that should get us up to date with our documentation. And again, we're going to have to rm-rf docs and now make docs-pdf. All right. WSL view. Yeah, I don't have it open already. Docs, HTML, index. Here we are. And now we're going to look. So we've got our files a little more simplified now. That is, we've got our cast, unary, binary. We've got our types. We could have called them AST node literal Boolean, but they're not derived from an AST node literal type. Whatever. And same way for here. We've got all of our documentation there. So let's just look at the AST node binary operation. Yeah. Okay, so those are showing up. That's always good. And yeah, and it does link to the type. Good. I was wanting that. And so for our, just to make sure, we've got binary, cast, and unary. Ain't that a pretty graph? Oh wait, these are the file references. Sorry. Classes. Binary, cast, unary. And they should all have enum type operation. Okay, so that has, this has its enum type there. That doesn't need any hyperlinks. And operator. Oh, negative and not. We need to add that one. Okay, AST node unary. Just to make sure, yeah. Let's do that. Include AST node unary. Do you know why? Because you have to do that. Simple enough. Open this back up, refresh it, and we have our documentation. Good. Like, I thought I got it all. You never know. All right, so there were some of these that were huge. Like really, really wide. But it might be taming down now that we've got now we're simplifying our classes. So anyway, all right, well, you know what, this puts us, we are, oh, this is all docs, so git add docs, just make sure that, oh yeah, and what are the changes I made there? That's fine. What episode is this? Is this 20? It is episode 20. Never thought I would have had this many out. Also, I thought we would be much further. But the truth is when you sit down to start programming, you get, into the flow and you just work and work and work, and you never realize how much time that you spend. And I have to think of what step can I take that's hopefully less than I was going to say an hour. I think normally we've been, oh no, this is barely over an hour. So that's good. But I don't want to bore you to death. Too late for that, Corey. Oh well. But something that's small enough that we can attack it and get it done, because this is a personal thing. I always want at the end of the episode for it to be compiled and, safe for you to take and play with. So in fact, I want to make clean and make tests just to make sure. But it's, yeah, that's my goal. I always want it in a safe, steady, stable, maybe is the word, in a stable state at the end of the episode. So yeah, okay, there we've updated the documentation. Git push origin master, and now git tag -a episode.020, and our message is going to be the same, episode.020, and git push origin episode 20. All right, new episode down. And for the next one, I'm thinking we can knock out all 6 of the comparison operators in one video. The reason is because, and I'll talk about this next time, you only need 2. You can choose either less than or greater than, either one of those, and equal. And between that and the fact that we have a logical not, then yeah. I'm thinking out loud. But between those two, you can, what is great, if you only have a less than and a not, then what is greater than? It's not less than and it's not equal. And if you've got those 2 tests, then you can do your greater than. What about greater than or equal to? It's not less than. What is less than? Well, less than, you've already got that. Less than or equal to, you've got those 2 tests. Equal to, you got that. Not equal to, just do the equal to and take the logical not of it. So, yeah, all of this is be just fine. So, having said that, I think we may attempt that, and that would be nice. And after that, we might start trying. After that, we've got to start doing expressions. These are expressions, statements. Being able to do one statement after another. That means we need code blocks. And that brings in a whole other series of issues. But, okay. We'll work on it. For now, I think we are in a safe spot, and the information is pushed up to Git. And as always, hey, hope you've had fun. Have a great day.